Hello everyone. I am Professor Atiya Khan from All India Shri Shivaji Memorial Society Institute of Information Technology. Will now brief you all regarding background of engineering mechanics. Mechanics is evolved from our ancient times. Many scientists have made sincere contributions to the field of mechanics. It is through their hard work and research of which evidences are found from experiments performed by each one of them. These scientists or researchers finally presented principles, laws, and theorems to the world which are accepted worldwide with the demonstrable truth. The study of mechanics was developed very early in history. Early contributions were made by Aristotle and Archimedes. Aristotle dealt with the principle of lever, which enables to lift various heavy objects with comparatively lesser force. Archimedes established the phenomena of buoyancy. So, when the object is inserted into a fluid, a buoyant force is entrusted through the fluid onto the object, and the object is lifted with the force. So, when a 5 kg of object is submerged into the liquid, into the fluid, the say 2 kg of buoyant force is entrusted from the liquid below the object, submerged object. Then the 2 kg of liquid or the fluid will be spilling out of the vessel, and the ultimate weight of the object into the fluid will be 3 kg. Galileo introduced time factor in the study of effect of forces on bodies. His experiments with motion of pendulum and falling bodies contributed to deeper study of the subject. In the picture below you can see the experiments done by the Galileo for the falling bodies. Sir Isaac Newton contributed most significantly to mechanics through the theory of fundamental laws of motion and the laws of universal gravitational acceleration. So the law, first we all know the laws of motion. First law of motion, when the object is in the stationary condition or it is having a uniform motion, it will continue to stay at the same position or in the same state until and unless the external force is applied to it. The second law of motion is F is equals to ma, that is the resulting force acting over the body will change the will be responsible to change the momentum or the rate of momentum of the body. The third law of motion is every action has equal and opposite reaction. So here we also have the gravitational law, that is when the two bodies are kept away from each other, the force of attraction between the two bodies will be equal to the product of the masses and will be inversely proportional to the square of the distance between them. So if we are observing a projected body or a falling body, then the force of gravitation between the earth and the projected body will be equal to the product of the mass of the body and the mass of the earth, and divided by the square of the distance between the center of the earth and the center of the body. Then Varignon, a French mathematician, along with Newton, presented the law of parallelogram, which states that when the two forces are represented as the sides of a parallelogram exerting from the same on the particular point, then the diagonal drawn from the same point will be representing the resultant of the two forces. Then Max and the Planck and Bohr made contributions in the area of quantum mechanics. Quantum is the smallest quantity of some physical property that a system can possess. Then Einstein formulated the theory of relativity referred to as realistic mechanics. So Einstein referred space, time, energy, matter, all these, and he came up to an equation E is equals to mc square, that we all know. Energy equals to mass times the speed of light square. So the theory of relativity was presented by Einstein. Then Einstein challenged Newton's law of motion. However, it is found that Einstein's theory has certain limitations and could not be applied under normal circumstances. Newton's law, therefore, forms the base of mechanics and is Newtonian mechanics. So, it's all for today. Thank you very much. Have a good day.